In this video, we are going to analyze in detail and compare two types of compressors used in automotive air conditioning systems: the traditional compressor with mechanical clutch and the modern electric compressor for climate control. Throughout the analysis, we will see how they differ in operation, performance, maintenance, and costs, as well as the impact they have on vehicle efficiency. 1. Power source. The electric compressor is powered exclusively by electricity through the battery and the alternator. Its great advantage is that it does not depend directly on the gasoline engine to operate. On the other hand, the traditional compressor with clutch obtains all its power from the mechanical drag generated by the engine through a belt. This means that its operation is limited by the performance of the thermal engine. In the case of some high-capacity electric compressors, it is important to consider that they might require a higher power alternator to meet their energy demand. 2. Operating speed. The electric compressor works at a variable speed that is electronically controlled precisely according to the cooling demand. This allows it to operate exactly at the power required at any given moment. In contrast, the traditional compressor with clutch is directly linked to engine revolutions. If the engine spins faster, the compressor does too, and if the engine runs slower, the compressor performance decreases. 3. Operation with engine off. One of the most notable advantages of the electric compressor is that it can continue cooling the cabin even when the engine is stopped, which is essential in hybrid or electric vehicles, or when waiting at a traffic light in high temperatures. In contrast, the traditional compressor stops working completely as soon as the combustion engine is turned off. 4. Fuel consumption and alternator load. In terms of consumption, the electric compressor does not exert mechanical load on the combustion engine, which can reduce fuel consumption compared to the traditional system. However, it does increase the demand on the alternator, which in turn consumes engine power. Despite this, its electronic cooling production control helps avoid excess by generating only the necessary amount of cooling. The traditional compressor, on the other hand, transmits a direct load to the engine through the belt, which increases fuel consumption and sometimes produces more cooling than necessary, wasting energy. 5. Operation at low RPM. In heavy traffic, or when running at low revolutions, the electric compressor maintains its efficiency consistently thanks to its independent control from the engine. The traditional compressor, on the other hand, loses cooling capacity at low RPM, which can be uncomfortable on hot days when the vehicle is stopped or moving slowly.